Students, the next topic is introduction to flip-flops. Okay, introduction to flip-flops. So what exactly is flip-flop? Okay, if I have to talk about flip-flop, I can say that flip-flop is a storage element. Okay, it stores a bit. Okay, you know, in case of a digital system, the bit can either be a 0 or a 1. Correct? So all of us have a confusion against what exactly is a latch and a flip. Okay, let me tell you all the difference between a latch and a flip-flop. Okay, I'll quickly brush up through the difference between the both. Okay, a latch is a simple basis for flip-flop building. Okay, and a flip-flop is built by connecting some additional components. It is built by connecting additional components across the latch, or I can say that around a latch. The next difference is latch is level triggered. I'll tell you all what exactly is level triggered. Level triggered, either positive or negative level triggered. Okay, so I'll just give you all or explain to you all what is level triggered. Okay, here flip-flop, we very well know, is pulse or clock edge triggered. That is clock edged trigger, clock edge triggered, either positive or negative. Okay, either positive or negative. And the last difference is the latch output responds to input until active level is maintained at the enable input. That is, the active level has to be maintained at the input level, Here, the flip-flop output responds to input only at specified edges of clock pulses. Only at specified edges of clock pulses. Okay. So these are the major difference between a latch and a flip-flop. Okay. So flip-flop basically is a storage element. Clear? So let us understand, okay, what exactly is the level triggered and edge triggered. Okay. So the next topic which I'll be explaining to you all is level triggered, because these are important to know exactly the working function of the flip-flop. Okay. So let me explain to you what is level triggered. Okay. So level triggering. So in level triggering, the output is allowed to change according to the inputs. The output is here allowed to change according to the inputs. Okay, according to the inputs. Either positive or negative edge is maintained at the enable input. This is very important. So here the level triggering is the output is allowed to change across the inputs. Okay, that can be either your positive or the negative edge at enable input. Okay, now there are two types of level triggering. So one is your positive level triggered, and the second one is the negative level trigger. Okay, so what exactly is positive level triggered? So dear students, understand this. The output of the flip-flop response to the input changes only when the enable input is high. This is very important. That is what is the positive edge. I shall show you all with the diagram. So let me start like this. Okay. So let me say this is your 0, and let me say this as the flip-flop, and let me consider this too. That is, the flip-flop is enabled only when the level E input is high. Okay, so I can say my enable input is this. Okay, and this is 1, and let me say this as 1. Okay, this is what is your positive level triggered. That is, the flip-flop is enabled only when the level of E input is high. Okay, so here this is the condition. Okay, whenever your level, that is whenever your level of E input is high, you say that as the positive level triggered. Okay, now this is one of your level triggering. Now let us see what is the negative level triggering. Okay, so I'll explain to you all what is negative level triggering, and let me explain that with the diagram again. So negative level triggering is something like this. If you're considering a clock period, let this be 0, and let me consider this, and let me consider this again, and let me consider this. Okay, so these are, let me say that flip-flop is enabled only when E, that is enable input is low. You can see that very well in the diagram when I started pointing this low areas. Okay, 0. So flip-flop is enabled only when the E is low, and that condition is called as what? It's called as negative level triggering. Okay, so in case of level triggering, there are 2 types, and this is what is your negative level triggering. Okay, so this is nothing but that it is 1, that is nothing but your enable input, and whenever your enable input is 0, your flip-flop is enabled only at E is equal to 0. This is your negative level triggering. Okay, now you have to know, apart from the level triggering, there is something called as edge triggering in case of a flip-flop. So I'll quickly brush up through what is edge triggering. So the next topic is edge triggering. So what exactly is edge triggering? Here the output response, in case of the edge triggering, responds to the changes in the input, only at positive or negative edge of the clock pulse at the clock input, Okay, so this is what is your edge triggering. See, students, concentrate here. The output responds to the changes in the input only at the positive or negative edge of the clock pulse at the clock input. Now again, the edge triggering is of 2 types. This is positive edge triggering, okay, and there is something called as negative edge triggering. So these are the 2 types of edge triggering. Okay, so I'll explain again with a diagram over here for your better understanding. So what exactly is the positive edge triggering? Okay, so positive edge triggering, let me show you all. So let me consider the clock. Okay, so here, and let me consider this, or let me highlight this point to you all. Okay, so this portion and this portion, that is, I can say that output response only at positive edges of the pulse. I think you could have understood this by seeing the diagram. Here you have a 0 and here you have a 1. So let me say this as my clock input. Okay, and let me say this as my V, right? So you can very well see that this is the rising edge, right? This is your positive edge of the clock, right? From 0 it goes to 1. Okay, so where exactly you come across your positive edge of the pulse, your output response, and that is called as positive edge triggering. I think this is clear to you all, students, right? Now next is the negative edge triggering. Let me draw that again for you all. The negative edge triggering is what exactly is negative edge triggering. Okay, so the negative edge triggering is, just have a look on the diagram. So this is what it is. Okay, so here I think you could have understood by this time, right? So this is my 0 and this is my 1. And you can see here, let me consider this portion and let me consider this portion. Okay, so this is, I can say that my output response only at negative edges of the pulse. Negative edges of the pulse. You can see that, right? So here is my negative edge as well as here is my negative edge. Okay, if I'm considering the clock period. So my output response only at the negative edges of the pulse, and this what is a negative edge triggering. Okay, so these are the basic things which we'll have to know when a flip-flop is considered. Okay, to get into a depth of different types of flip-flop. Okay, so let me quickly tell you all what are the applications of flip-flop. So what are the applications of flip-flop? It can be used, as well as we know it very well, it can be used as a memory element. Okay, it can be used as a memory element, and it can be used to eliminate key debounce. Okay, the debouncing of the key can be eliminated by the use of flip-flops. Okay, it can be used as a delay element. It can be used as a delay element. So these are all the basic functions of the flip-flop. Okay, another thing I can also add is it can be used as the basic building block in sequential circuit. Correct? In sequential circuit, it can be added as a basic element, such as, if I have to give you an example, for counters, registers, etc. Right? So these are all the basic, applications of the flip-flop which is widely used. Now, dear students, we have understood what is a flip-flop, a storage element, and what are all the features a flip-flop can have. Like we studied about the level triggering in the positive and the negative level triggering. Then we studied about what is the edge triggering, and in the edge triggering we saw what is positive edge triggering and the negative edge triggering and the applications, which is very important for us to get into the truth table and the excitation table of the flip-flop. Correct? So let us now study the various types of flip-flop. So let me quickly take you all through different types of the flip-flop. Okay. So we have, the different types of flip-flop to study is, we have D flip-flop, T flip-flop. Okay, we have different types of flip-flop. Okay, you have D flip-flop, T flip-flop, JK flip-flop, and you have SR flip-flop. Okay, so these are the 4 flip-flops that you have to study, and in the flip-flops you will have to study about the truth table. Okay, you have to study about the truth table of various flip-flops, and you will have to know about its excitation table. Okay, so let us quickly go through the excitation table of different flip-flops and the truth table. Okay, now what exactly is a excitation table? Okay, so excitation table, let me tell you all that. A truth table that lists the required inputs. A truth table that lists a required input conditions for a given change of state. For given change, very important, change of state is called the excitation table. Okay, so I'm going to tell you all the truth table and excitation table of all the flip-flops. Okay, so it is required input condition for a given change of state. That is what is your excitation table. And dear students, you have something called as the characteristic equation for all the flip-flops. Okay, so if you just know the characteristic equation is enough. So I'll just quickly write down for you all. For SR flip-flop, it is Qn plus 1 is equal to S plus R bar Qn For D flip-flop, it is Qn plus 1 is equal to D. For JK flip-flop, it is Qn plus 1, that is J Qn bar plus K bar Qn. And for T flip-flop, it is Qn plus 1 is equal to T Qn bar plus T bar Qn. Okay, so these are the characteristic equation of all the flip-flops. Clear? Now coming to the D flip-flop, let me quickly give you all the truth table and the excitation table. For the D flip-flop, the truth table is something like this. You have a D and you have the next state Qn plus 1. Okay. For 0, the condition is 0. For 1, it is 1. So this is my truth table for D flip-flop. And what about the excitation table? The excitation table is, you have the present state, you have the next state, and the status of the D flip-flop. For 0, 0, it is a 0. For 0, 1, it is a 1. For 1, 0, it is a 0. And for 1, 1, it is a 1. This is the excitation table. And this table, we know we will require this for solving almost all the problems in case of the sequential circuits. Clear? Now coming to the T flip-flop. Okay. So we know that in case of D flip-flop, this is what is the truth table. So let us quickly run through the T flip-flop truth table and the excitation table. Okay. So the truth table for the T flip-flop is, you have a T and Qn plus 1. For 0, it is a Qn, and for 1, it is Qn bar. Coming to the excitation table, it is Qn, Qn plus 1 and T. So for 0, 0, for T to be 0, your present and next state has to be 0. That is what it signifies. And for T to be 1, your present state has to be 0, your next state has to be 1. And that transition gives you a 1 in the T flip-flop. And next condition, present state 1 and the next state 1, 0, gives you a high on the T. And the present state and the next state 1 gives a transition of 0 on the T flip-flop. This is the excitation table of the T flip-flop. And next is the truth table and the excitation table of the JK flip-flop. So J, K and Qn plus 1. You have a 0, 0 and here it is Qn. For 0, 1, you have a 0. For 1, 0, you have a 1. And 1, 1, you have a Qn bar, if I'm not wrong. And the excitation table is, you have Qn, Qn plus 1 and J and K. So you have a 0, 0, 0, 1, 1, 0, 1, 1. If you have to get a 0 and a don't care, which can be either 0 and 1, here it is 1 and a don't care, here it is don't care and 1, here it is a don't care and 0, which can have a state of 0 and 1 either. Okay. So for any state transitions, these are the conditions that a J and K must have. Okay. And the last flip-flop is our SR flip-flop, the set and reset flip-flop. Okay. So the truth table of it is, you have SR Qn plus 1. So it is 0, 0, which gives us a present state. For 1, 0, it gives 1. For 0, 1, it is 0. And 1, 1, it is actually for 1, 1, it is said to be a don't care state or ignoring state. And coming to the excitation table, it is Qn plus 1, S and R. You have a 0, 0, 0, 1, 1, 0, 1, 1. So here you have 0 and don't care, 1 and 0, 0 and 1, and don't care and 0. Okay. So dear students, these are the basic fundamentals of a flip-flop, and you have to know the truth table and the excitation of all the flip-flops, which is very much essential for you all to carry on with your design problems. Okay. Hope you have understood this session. Thank you.